computer. Okay, here we go. All right. Well, welcome to the first official class, everyone. So hope things are going well. Just a couple of quick announcements in case. Well, first of all, if you haven't seen the introduction video from Friday, it's up on the course website, right on the homepage. I also, for those who are interested, I did end up posting the orientation. That video recording is up. Although I think if you do the intro to the course, I think you'll be fine. There's some overlap there for sure. Oops, where am I going? Go back to the slide. So what you should be working on now is lab 1, and lab 1 is all really we're trying to ease into this. The course will accelerate. I will warn you, but we got to cover some basics in the first few weeks. So for some of you, this might be review. Some of you might not be. But work on lab 1. That'll be due Sunday evening. I think I mentioned this too in the Friday. When you're submitting the labs, there should be a little italic or a little text in there that says insert your answer here. I recommend just insert your answers and leave. You can leave all the other text in there. We know how to scroll through it and find it. So that's and that'll just be easier for yourself in the future if you're going back and you want to review any of these things.
How can we actually view which? Because I'm on the fall 2023 website right now, and when I'm in the labs section, is that where we actually
good
view the
question.
assignment?
Yeah. So what I would do is look at actually the software page, and particularly this data 606. So to get started, let me delete these folders because I have some remnants. So if you so first thing you want to do is install the data 606, and it's not on CRAN, so you got to do the remote install GitHub, right? And you would do JBriar. I'm not going to run this, but I will copy and paste this into the chat. Okay, so once you have that, you can load the data 606 package, and then you could say start lab 1. And what that will do is create a folder in your working directory. Actually, this is a good aside. I'm not sure they covered this in the bridge, but this is really important. So R has this notion of working directories, and this is where some students can get confused, and I can get confused myself. So I don't actually have a project. Another thing you might want to do is create a project, which is really just creating a folder. So you might want to create a data 606 project. But okay, working directory. So if I'm trying to work with files, like if I want to load a data file, I can specify a relative path, meaning I just want to say filename.csv. And if I just say filename.csv, where is R going to look for it? It's going to look for it in your working directory. There's a couple ways you can get that. There's a function called getwd. There's similarly a function called setwd. Okay. Or in the console, this right here, right? So this tilde, because this isn't running on an Ubuntu so this tilde means it's my home directory. If you're on a Mac, you kind of have something similar. If you're on Windows, it's probably like something like C:/ whatever. Okay. So, and if I do a function like list files, right? It's just going to look at my current working directory, which happens to be what's over here in this right-hand pane. Okay. So a couple of things you can do, right, is you can click this little arrow. And what this little arrow does is makes your file tab go to your working directory. Now, what you might want to do is I'm going to go into lab 1, and under this gear icon, there's this set as working directory. Okay. So now you can see it actually ran the command. And if you look here now, it says lab 1. So if I do list files again, right, I get a different result because now I'm in a different working directory. Why is this important? So in a lot of the labs, you're going to load data sets. So let me find. So this is going through some install. Where is it? Here. Well, actually, I changed a lot of it. So a lot of the data comes, but there will be some later ones that will look for other files or what have you. Now, as you're working through the lab, you can run these commands, right? So if I hit Command Enter, or I guess it's Control Enter if you're on Windows, I can run things line by line. I can hit this plus button, which is going to run everything in that chunk. This arrow will run everything up to this point, right? So if you're coming back and working later and you want to get your R session, environment set back up, you can do that. Now, what happens is like with our markdown files, when you click the knit button, which is actually going to generate the PDF, essentially it is creating a new R environment and starting the working directory wherever that RMD file is. So sometimes where the RMD file doesn't match your working directory as you're working interactively. Okay. So a lot of times it's handy to go to where the RMD file is and then say, set my working directory so that knitting and working interactively is essentially the same in terms of file paths. Does that make sense?
Yes.
Okay.
Professor,
Oh, okay. Thank you, Angela, for answering the question. I'm sorry. Go ahead.
I'm sorry. I started working on the lab and I did not know. So what I did is obviously I don't have much background on programming. So I copied the template that you have on the lab and I copied it in R and tried
For this
to run
week, that's
them.
probably fine. But I think you're
Okay.
going to find it easier to use that start lab function.
Okay.
Because as you can see, there's a whole bunch of supplemental material files than just the RMD. So
Okay.
we tried to write a function to kind of make it a little bit more convenient to get everything. So you're probably fine if you copy and pasted it over. It should be the same. The links on the website actually point to. So if you hit this template,
That's what I did.
yeah, this is the source from the Data 606 R package. So they're the same. They're the same, but you know, and for the first couple of labs, it's probably fine. Like I said, I forgot. I think I don't think that Arbanath data set is here, right? So you could source it, but now they're all in the open intro data, or there's a package open intro that has that. So then
the
another
actual assignment is wherever it says insert your answer here within the first lab.
Yep.
Okay, cool.
That was a new addition over the summer. Hopefully I got everyone. So if you miss any, let me know. If you're like, oh, I think there should be something here, it'd be great if you can let us know. Going through 10 labs, trying to revise them every semester, I tend to miss something. So Tony, you're asking if you clone the 606 and set include that path into wherever your project runs from.
I'm not asking them. That's what I did. I cloned it, then I.
Okay. You could do that, but I think using the remotes install GitHub, then you can just run it as an installed package. Might be a way to go. Oh, when you clone it, include it. I don't know if there's anything in the include. I guess that's where I'm a little confused. So this is an R package.
Yeah, I just set the working path of all those files into the directory that I was in.
Yeah, so in the R, yeah. So the labs are actually in the inst labs folder. So you can see that's where they come from. We're also going to use, these are a bunch of Shiny apps that we'll use throughout the semester. So they're in there, and I'll show you how to do that when we get to that point. The textbook is actually included as a vignette, and there's a few demos and there's some data sets that we have in here too that we'll use throughout the semester. But another time, or I can share later if I can track it down. Last year I gave a talk on R packages, or developing R packages. I can share that on the Slack if you want to watch that. Yeah, whatever works for you, I think is fine. But the start lab function, I think will be your friend going forward. 'Cause like I said, some of the labs have some extra data sets and things, actually utility functions and the like that, it might not come across.
And our submissions for the labs, do you want us to knit them to PDFs, HTML?
Please,
yeah,
PDF.
Okay.
Because you can't submit HTML to Blackboard, and we can annotate PDFs in terms of giving feedback that you can't do in HTML. So.
And if you were to upload an RMD file, we have to download it and then run it. And so that's an extra couple of steps. So PDF would be Yeah,
That's
ideal.
yeah, ideal. Yeah. What else? Anything else to say about labs?
So just to confirm one thing, the remote install GitHub. So every time we're doing our labs, you have to do that one first, right?
No.
No?
So install.packages and install_GitHub,
Right.
which is in the remotes package. You install packages like once per R version, really, and actually major version. So R, right? So actually I think I have an old version on this Ubuntu server. I'm on 4.2.2. What am I over here? I think I'm up to date on my desk. What is the current version? I have 4.3.1 on my desktop. Okay. So when I say major, it's really this number here, right? The major happens on average every 10 years, I think, is when they go from like it's been a long time since they went from 3 to 4. But going from 4, so 4.3 will probably come out sometime this fall. They usually increment that in the fall, and then they do at least one release in the spring. But sometimes more than one if there's bugs that are worth fixing. The language is fairly stable. In the next upgrade, they're introducing a new object-oriented framework. I think this is like the 7th or 8th object-oriented framework. If you're not into programming, that won't matter to you at the moment. If you're just doing data science, it may never matter to you. So, but anyways, that's not a huge deal, but be aware that there'll be a new version. Actually, this is from last November. Oh yeah, this is my Ubuntu. I have on my desktop was released in June. Okay, point being, 4.6. Where is that coming from? So there's a function called libpaths. And so this lists out all the places R is going to look for R packages. So when you click install, or you do the install.packages or remote install GitHub, if you're installing it from GitHub versus CRAN, it's going to put the package in one of these directories, typically the first one. So what I can do is copy this, right? And note that it says 4.2, not 4.2.2. So if I click this little button, I can go here. And these are all the packages I have installed in this directory. And Data 606 is not one of them because I probably installed it globally. So it's probably in the not my home folder, but in one of these. Okay. So what it does is it's sequentially. When I say library data 606, when I'm going to load something, it's going to look for that package in this folder. If it doesn't find it, then it's going to go here. If it doesn't find it, it's going to go here. If it doesn't find it, it's going to go here.
Okay.
And if it doesn't find it at all, that's when you get that error message like, what was it? The namespace, maybe a kind of a cryptic error message, but that means couldn't find the package. You don't have it installed. Okay. If I update my R here to the latest version and it goes from 4.2 to 4.3, I have to reinstall my packages. All right. So it's like when this number increments, you're going to have a new library. If you do some Googling, people have written tools that says, well, let me go look at all the packages from the last version and either copy them over, but more than likely you just want to do a reinstall because in case there was some kind of binary change to it. But anyways, that's a little bit of background on how R finds things.
Thank you.
So the install once per R version, the library every time you want to use it. So if you create a new session, you got to recall it to make the function and data and everything in that package available to your session.
Okay.
And, RStudio has some really handy tools. So this environment here right now is my global environment, but every package, so wow, I have a lot of packages loaded right now. Every package that is loaded gets its own environment, and you can actually peek inside some of these. So what was I, here's the data 606. So if I click this, now my environment. So I have this data set that's available, and then a whole bunch of values, and then here's some functions, right? So you can I almost never do that, but that is something you can do to kind of explore packages. Usually the easiest thing to do is just do question mark, data 606, usually package name or something, it gives you some documentation. Like next week, we're going to talk about ggplot2, which I think you should have, if you've done the bridge, you probably got introduced. I can do that. And it's going to, I can start going through, and a lot of times I go to the index and here's a list of all the functions and things that are available. And you can do little searches in here. So if so usually the first step is like, which package do I need to do this thing? And usually Google gives me that answer. And once I find the package, like what do I need to use in the package? This is where I end up, is in this help documentation. But like you can do question mark anything or any, and I could do that start lab, right? So you can see here's the lab. The first parameter L is the name of the lab. The destination directory, where do you want it? By default, it sets to the working directory, but you can override that if you want, right? So this is what you'll see, Angela, and I do this all the time. Like when you ask questions, like, I don't remember the parameters of that function, I do that question mark in the function and I have it over on the right-hand side. Why is it .libpaths instead of libpaths, Tony? I think it's a way of indicating it's kind of an internal function. There's some base R functions that start with a dot. That's unusual if you came from another language. Dots are often reserved for usually like function separators. Like if you're doing object-oriented programming, I think in Java, it's been a long time since I've ever done some Java, right? You would do object name dot function. In R, we use a $sign. The $sign takes on the dot, and so the dot can just be used. There's probably some history to it, and I just don't know off the top of my head, but I think they often use it to infer this is kind of a private function, although it's not really private because it's exported. Okay, there is some debate because Hadley Wickham, whose name you will probably become familiar with if you keep up in the R, he's the chief data scientist for Posit, which RStudio changed their name to Posit last year, if you still know it that way. The company is Posit, RStudio is their IDE. They did that in part because they're trying to be more than just R focused and more broadly data science focused. So he's fully an R programmer. He's done some work with Wes Kinsley, who's sort of one of the leading Python developers, and they've done some really great work in terms of translations. But he's an underscore person versus a dot person. And so you'll see in the tidyverse underscores used everywhere. If you look in base, like that list dot files, right? That's a base R function. And here's another little trick is if I don't put the parentheses, it's just going to give me the source code for the function. So you can always interrogate in R, the source is kind of always available. Now, it turns out, in this case, you see this dot internal. Here's another one, Tony. This is base. I think I might have mentioned R is a glue language, right? It has its roots in S, and it's designed to work with other languages. So this dot internal, so I don't know, the core 40% or so of R is written in C, and then the rest of the language is written in R. But there is a lot of C code, and dot internal, I think, goes into a C library. So when you see that call, that means it's calling into C now. JB, you have your hand up? Question?
Yeah, I just had a quick question about formatting for the lab.
Mm-hmm.
The first question where you have to do like it's about like the girls baptism rate, I think, or baptisms. It asks you to like type out your interpretation of the trend along with like where would we put?
Yeah, I realized I don't have the latest version of the package, so I don't have my little notes here to tell you. So what I would do, so I mean, we could do this one together. So what years are included in the data set? So couple things, I usually just type it by hand, but I think, where is it? Yeah, here it is. Okay. Do you guys see this drop down when I click it?
Yeah.
Okay. I can't, sometimes I can't tell what, some dialogues come through on Zoom, some others don't. right? So here, actually, so I could just insert an R chunk, right? And it's going to do that. But you could see I could do bash, D3, Python, SQL. So what I would do, and so what I need to do is actually run everything up so I could see, okay, so there's the Arbuthnot, right? And so I might interrogate this, right? I'm going to look at this and say, okay, year, right? So I might need to, use year. There's a lot of different ways I can do this, but I can do range, Arbuthnot, year. Okay. What years are included? What are the variable column names? So, and then I could just say, sometimes just putting the R code in is sufficient. If you want to be complete, I could say, the years go from, 1629 to 1710. The variable name, is year, right? I can just type it here. That's fine.
So the only thing we put in the R box is the actual R code. We don't like comment anything out in there.
Well, I mean, if I put this here, then I need to make it a comment,
right?
Because everything inside this is going to be run as R code, or alternatively, the beauty of R Markdown is I can have some R code, and I can have some text. I can have some R code, I can have some text, right?
So you guys would prefer it to be outside of the code box, code chunk?
Honestly, I don't think we care, but it looks better if it's out. And so maybe, for now we're kind of this first semester, but start thinking about aesthetics, that starts to matter. Now here's another little trick. If you haven't noticed yet, you can do inline like with one tick. Right. So if I do that, now I could say min Arbuthnot. I can never spell that. So I'm just going to do this. Right. And then I can change this. Right. Like so. Now, and when I'm in interactive mode, I can highlight a subset of text and click run selected line. Right. I see it's 1710. Or I can highlight this. I tend to just learn the shortcut, command enter, right? And so when I knit this will become 1629, and this gets converted to 1710. So there's a little trick, something a little fancier. This is amazing when you're trying to create reproducible reports. This is one of the reasons why I learned R a long time ago. I could say it's been a long time, but I was a single researcher in a one-person shop, and I had all these mundane reports and numbers I had to give, and so I wanted to automate these things as much as possible. And so I could, the data changed monthly, and so every month I could just on the first generate my PDF reports in the old-fashioned way using something like SPSS. It could take me days to create those reports. So this just streamlines everything a lot. All right. Well, we went way off.
Thank you.
We didn't even get to the slides. So I just threw in, I realized it kind of automatically redirected. Let me open a new tab. There are a ton of really useful cheat sheets. They're all usually roughly 2 pages. So the ones I would recommend for now that you might just want to have available, you have the R, if you're just getting familiar, if you've new to programming, you've never used an IDE, the RStudio IDE cheat sheet is great. Then Luberdate to some extent, but let me see here. dplyr is one you're going to want, particularly probably for 607. You're going to dig into dplyr more in 607, but I'll start to use it. But for us, ggplot, I'm going to really encourage you to use the ggplot framework instead of base R. I think we took a lot of the base R stuff out. So there's a lot of really useful like cheat sheets there that are available. I just want to make you aware of them. All right. Sorry. One thing I did notice is I was starting to try to summarize your DAX results. I'll try to do that for next week, but I would say about 60% of you did that, which is fine. We didn't say there wasn't, it's not technically due until Sunday, but if you can go in and do the self-regulated learning assessment in DAX, we'll look at that next week. I can update this again next week, but these is from that Google form. I just like to look at this. I like to share it with you. Angela and I find this, I think, somewhat informative, just kind of see where people are, that everybody's familiar with visualizations and descriptives. So like I said, tonight and next week might be review in terms of the descriptives, but we're going to show you how to do these things in R, which might be new for, I think, quite a lot of you. So bear with this if it's a review. Angela's going to take the lead on the probability section. So it's good that you have a lot of familiarity. We need to lay out some definitions as we go through. So I'm really happy nobody knows anything about SPSS, and we're not going to teach anything about SPSS. So ANOVA is kind of mixed. So a lot of this stuff down here, chi-squared, null hypothesis, that's going to be the meat of the course as we go through. So you can kind of see where everyone is. This makes me super happy that you all think you're going to use math in the future and that you find it interesting. I love looking at this. I should put some comparisons because I've taught statistics in education context. I even taught in criminal justice for a year, which was super interesting because I knew nothing about the content. So students came in with really interesting data sets that I'm not used to. So I learned as much as they did. But they did not find math interesting. They were only there because it was a requirement. And so I love seeing this mix, and I love this program for a lot of this reason. So the only thing I'll say here for both Angela and I, we get life is complicated. Things are, and going to grad school can be intimidating. So we're trying to look at, and from our research, we kind of know things like self-regulated learning, affect, mindset, those kinds of things are really strong predictors. So if you feel uncomfortable about any of this topic, you ask questions, right? We're trying to make it safe for you to seek help, right? There is no dumb questions, and we're happy to answer and kind of get through things. So this is another way for us to kind of put that out there. Do you want to add anything to that, Angela? We both kind of over the years deal with students from everything like I'm overwhelmed by this to, what have you.
Yeah, I mean, one semester we met with one student who was working on a thesis. I mean, that was beyond this course, right? But I mean, that's how open we are. Just simple. So reach out. If we don't respond on Slack and it feels urgent, just email us. Email both of us, and one of us will respond.
All right. Well, let's go in. So the first chapter is sort of foundational stuff. And there's some things in here that I think are really important for data scientists that is, in my reading of a lot of data science books, underemphasized. And Angela and I are kind of steeped in this in part of our DAX project. Like measurement is a huge thing. Like we developed an assessment and feedback framework, right, to predict student success. So there's a very big data science, right? Predicting outcomes is what all data scientists are going to do a lot. But a key, those predictions are going to only be as useful as the measures that go into those models, right? And I'm going to implore you, because I meet so many data scientists, like, show me how to run the model. And I'm going to do, compare my model metrics. But it's worth taking a moment and thinking about the variables that are going into your model, right? Are they valid and reliable? So there's a whole section in chapter 1 about valid and reliable. And if you look, across the field, like you're going to see all sorts of examples where things got wrong, right? Amazon for a while was using, predictive models in their hiring practice. I just listened to a talk this afternoon because I have a junior, right? We're starting to look at colleges, and they were asking, is the admissions process going to start to use AI? And I'm like, oh God, I hope not, because we know there are biases in the admissions process. And if you start training models, they might seem good, right? But they just reflect reality. And that's because they're putting in what I might argue is invalid or unreliable measures. Right. So in the Amazon hiring case, if you were a woman, hiring for a software engineer job or a data science job at Amazon, you were very unlikely to get an interview because they trained it on data where, I don't know, 80% of the employees are male. And if you include sex into your predictive model, then you don't hire females. So then your model doesn't predict females, right? Google kind of had another really embarrassing when they were doing their image classification. When they put it online, it was identifying gorillas as African Americans, right? That's really offensive, but it had to do with the measures that they were putting into their model. And we don't talk about this enough. So if there's a couple like little things that, we're going to try to instill in you as sort of, I think, ethical data scientists, this would be one of them. Think about the measures that go in. Right. And valid and reliable. So reliability is necessary, but insufficient for validity. Right. So we kind of talk about this in kind of, broad. And I love this sort of dartboard analogy. Right. So you can have, right. So not reliable. If you're throwing a dart, you're all over the place. But what a lot of researchers do is there's certain measures, right? Chromebox alpha is a classic, right? Which is akin to correlation that we'll talk about in a few weeks. So you can have reliable, right? Because they're consistent, right? In the case of Amazon's case, they probably ran reliability measures that looked reliable, but they weren't valid because it wasn't getting to what you wanted. They're consistent, but they're wrong. So what we're really always targeting for is valid and reliable, right? They're consistent and we're hitting the target that we want to hit. Now, and we're going to ask you to do the same, right? Find a data set and analyze it in some way. So you're not actually going to collect your data. So sometimes you don't have a whole lot of control over this, but you have control of what you do with it when you put it into your predictive models. So think about these things. You should ask your question when you're running a model and you're looking at the list of variables that are in your model. Is this a valid measure of what I think it is, or is it a proxy, right? There's a great website like Spurious Correlations. I don't know if you've seen this website so here we have suicides by hanging, it just gives you a random strangulation, suffocation, correlated with U.S. spending on science, space, and technology, right? These things happen all the time. Like the example I always like to give, New York City folks, as ice cream sales increase, so does crime. Does ice cream cause crime or crime cause ice cream sales? But if you put ice cream sales into a predictive model for crime, it's going to be a significant predictor, right? But is it a valid measure of crime? No, right? So please be careful.
This is also why we don't fish, right? We don't run analyses until we find something significant. We usually should start with a research question, something meaningful in your field, in your respective fields, because you'll find things like spurious correlations if we just go in and fish for something significant.
Right. And in our case, we have a very large grant. We were required to pre-register our study. So at the beginning of the project, we had to go and say, here's the data we're collecting, here's the statistical analyses we're going to do, and it's sort of there's a record of that. So now that we got data coming in, we're running those analyses. We can't change our analyses because of, this is what we said we were going to do. We're not going to fish for a significant result. Okay. I'm not going to, you can read this slide later, but right. What we're trying to get to here is this notion of randomized control trial. I'm going to imagine most people kind of know what's going on, right? So if we want to know causality, we need to have some kind of control. Okay. And the gold standard is randomization, right? So we're going to flip a coin and decide. So in our case, in DAX, we're running a study right now at Lehman College. We just met with them this afternoon. And so half the students coming in as freshmen are going to take DAX and get the feedback and use it in their class, and the other half are not. And so we went through a process, generated a random number so that half the students get it and half don't. So if we measure some difference in academic outcomes, it is because of the intervention. And the reason why that works is because all the other variables that could influence that academic outcome should balance between a treatment and control, right? And that's kind of the key of what that is. The study design is critically important. It's one of the few times we're going to really talk about it. What I think some students find surprising is we're going to learn all these statistical tests, and you can use them on randomized controlled trials, and you can use them on just observational studies. And getting to causality is not determined by your statistical method. It has to do with your research design. Okay. And this is getting more and more popular. I mean, Google made this famous, they call them A/B tests. It's just a randomized control trial. They do it on everything from deciding what shade of blue a link should be, right? And they'll do A/B tests and see how people respond to it. So that, you can do causality in lots of different ways. Right. So for sake of time, we'll skip that slide. Right. So we want to see if there's real differences. I think this is all probably pretty self-explanatory. So then the next step, right? So we have randomization or non-randomization to determine causality or correlation. And I'm using the word correlation sort of very broadly. Correlation just meaning that there's a relationship between two things. We'll define correlation formally in a few weeks. Okay. Then the next is whether or not something's representative. And this is a whole other separate issue, right? Going back to my Amazon issue, I would say using, some ways it may make sense to use pre-existing employment data, right? Thinking that's representative. And it's representative, yes, but it's also representing biases, right? So there's kind of a whole lot of complexity here. And so a couple of ways we can handle this. We can do sampling, right? And random sampling allows us to make generalization. So we're entering another long election cycle. And so we're going to start seeing a lot of polls. And I'll probably have more to say about polls and the Nate Silvers and the 538s in the world, because I think they're becoming less useful but historically, right, they worked because they were truly random samples. If I randomly, and we'll see it's usually around 1,060 or so, is enough to get a decent, standard error. If they're truly randomly sampled, I can take some proportions and say, well, that represents the population in general because they were randomly selected. It says nothing about cause. We're not talking about causation or correlation here. This is about whether or not my data represents something larger. Okay. The other approach is a census. In the United States, we do this every 10 years. If you're, I did a lot of educational research here where I would do census of all students at that institution because my population of interest is students at the institution, and I could literally measure every student. Okay. So that would be a census. And so you got some options, but to do a census is generally pretty expensive, right? The United States spends a lot of money every 10 years to do that. Okay. Now, when you're talking about sampling, you need to be careful of biases. So in the case of polls, one of the reasons why I think polls are problematic now is there's a large non-response. And unfortunately, pollsters don't often report the non-response rate. And that can be critical, right? And particularly because I think we have studies that know that there's certain type of demographics that are less likely. And for a long time, they would not they would only poll landlines, right? And so I haven't had a landline in a decade or longer, maybe 2 decades, right? So I would never get polls. I do now get text messages, but so they've kind of figured that out. You have a voluntary response, right? This is another, you need to convenient sampling. If you were on a campus, like when Angela and I go to UAlbany, I see little flyers all over campus, participate in our little study or take this survey, and you can get a gift card or something. So that's a voluntary response. There's going to be a bias who's going to do that. Oh, and then convenient sample, right? I might sample you guys in this class. Well, what can I say? Well, that might tell me something about MSDS students, But does that tell me about all graduate students? You know, you probably look different than graduate students in another program. Different types of random sampling, right? Simple random sample is like we have this population of you know, say students. You can just, these red dots are the ones we're gonna get. Sorry, 9-year-old interruption. We could do stratified sampling. So this can be really important. So say you want to make sure you know, have representation from all these different subgroups. So it could be by ethnicity, it could be by sex, social economic status, whatever it might be. So what you do is you divide, you have these stratum, and then you're going to randomly select within those stratums. And that ensures that you have sort of, you know, representation across. Oh, got a question? Go ahead.
Sorry for interrupting.
No.
So would an example of that be when Political Pulse will get a percentage, will separate respondents by race and then weight their final top line number according to what they expect the overall electorate composition to be?
Yes, that is, yeah, because you could do the weighting because they made the design choice ahead of time. The other way, yeah, that would be one way to do it. And that they're using a statistical adjustment to take into account the known difference in the likelihood of being selected. In other words, what they're doing is they might be oversampling minorities, right? For example, or, you know, so if you're a minority, your likelihood of being randomly selected is not the same as somebody from another ethnic group, right? And so because that was part of the sampling design, you can use what are called sampling weights to adjust for that. Is that what you're asking?
Yeah, I just wanted to make sure, because in the abstract, it was a little hard to understand. I wanted to make sure that I was correctly understanding that as an example of strata.
Yeah. So a simpler way to think about it is, so in the United States, we have a census. So we know, I don't know, I'm going to make up a number. Say 20% of the population is Hispanic, or, you know, identifies as Hispanic. What I might, in a stratified sample is, you know, I want to randomly select, I don't know, well, I'm going to have 1,000 people. So, and so I want a representative sample. So I'm going to say 200, I'm going to sample 200 Hispanic people and 800 non-Hispanic, such that the ratio at the end is 20/80, right? So I'm, you know, so I'm not just taking, here's everybody that's available and, you know, doing just sampling. That's a simple random sample. What I'm doing is like, here's a group, let me sample in that group. Here's a different group, sample within that group. And you can do it in a way such, you typically do this in a way so that the proportions at the end represent what I think the sort of population proportions are. But
thank you.
Yeah, that doesn't always work out, right? And so, well, let me do the example because this is where things get a little bit more complicated. So a lot of national studies, like things done by NSF and the Department of Ed, National Center of Educational Statistics. There's a big one, NAEP, that I happen to be very familiar with. It's often called the Nation's Report Card. If you see it in the news, they assess 4th and 8th graders in math and reading every 2 years, and they cycle in other subjects. But the bulk of, you know, it's kind of geared around this. It's congressionally mandated. They've been doing it since the 70s. The goal is to provide a sense of how 4th and 8th graders in the United States are doing in these academic areas. Now, doing a simple random sample is extremely hard, right? So they do what's called cluster sampling. So they divided the nation into regions. And so the first step, and it's actually multi-stage, they do more than one, but let me just go on one of the simpler ways. So actually, let me explain it this way. One way you could do it and kind of get the same idea is they're going to randomly select schools. Okay. And then they're going to go to that school and randomly select students within that school. Right. So in that case, a cluster would be every school or maybe a school district, right, in the country. So there's obviously more than 8 that are represented here. Once a school is selected, they're going to go in and say randomly select the students. And so this is another case where survey weights come in handy because not all schools are the same. So if you're in a small school, your likelihood of being randomly selected is higher than if you're in a large school district, right? Because if they're going to select 500, right, and you're in a school with 1,000 students, you have if your school was selected, you now have a 50% chance of being in the sample. If they're selecting 500 from a school of 5,000, right, and your school is selected and you're a student there, your chance of being in the study is 10%. And so because we know those things, we can do statistical adjustments for it, right? The key is the beauty of the simple random sample is the likelihood of being selected is 1 over the population for everybody. But then when you get into these either stratified or clustering, the likelihood of being selected is a little bit different because there's other kind of mechanisms going on. And if you're interested in polling stuff, right, they try to account for some of this stuff. Sometimes they do regional adjustments. There was I think it was Obama and Mitt Romney, that election. For a while, it looked like Mitt Romney was in the lead with African-American men. And for a week or two, because an African-American man living in like rural Nevada or something said he was going to vote for Mitt Romney. And that person had such a large weight when they did the aggregate that it kind of, it was an anomaly. He was an outlier, but it was an outlier with a weight because of these probabilities being adjusted for. So anyways, that was an interesting example. Is it Shaya? Am I saying that right?
Yeah, it's Shaya.
Shaya. Okay. Sorry.
Just the way you've been explaining stratified sampling, it seems, and if the target is to end up with a representative of the overall population, wouldn't that be the same as just doing a general sampling? You'll end up with the same, in your example of Hispanics being 20%. Either way, you should, assuming you're actually doing it at random, end up with 20%.
Theoretically, yes, but a lot of this course is we're going to learn about random noise, and if you have variables that matter and we can do better, we want to do better. So here's the example in sort of our educational world that I know is a hot topic, is understanding Native Americans. So that's a case where they represent like 1% or even less than 1% of the nation. So in simple random sampling, we often don't get enough data from that particular subgroup to make meaningful inferences because the sample size is too small. So the Department of Ed has started oversampling. So a lot of times when you do these, like particularly like stratified sampling, so in this case, right, it's not equal, right? Because we have Stratum 2 has far fewer people than Stratum 3, but we're still just selecting 3 people, right? So sometimes it's a way of trying to get data in groups that are really small that may have some meaning. Yes, is it, oh boy, is it Folu? How bad did I butcher it?
Not at all, actually, you got it pretty right.
Okay.
I was just thinking based on what Shaya was asking, like the strata helps to basically make sure that everybody's represented, basically, right? Because like in the standard sampling, like it's unlikely, but there's a very good chance that, for example, in a census or something, you pick all white people, for example, like everybody that identifies as Caucasian by accident, even though it was random, you just happened that way. Yeah. But this way, by putting everybody into like little groups first, based on a specific class, I should say, you kind of now end up giving every class a chance of being selected, right?
That's right. Yep. Yep. So you're correct. If you did a simple random, it should, but we can ensure it by doing this approach. Okay.
Question.
Oh yeah, sure. I'm sorry.
In the last slide, why not just take instead of taking 3 from each, taking,
on this one.
Yeah. Like, why wouldn't you just take more from the third, for example, then not have to wait at all after the fact?
You could. That would still be stratified and ensure balance. We could do statistical adjustments. So these approaches, like these stratified, Angela, add if I'm mistaken, there's sort of 2 major reasons why you might want to do this. One, you want to ensure that particularly small groups are sampled, right? And that and because you probably know the proportions, you can make statistical adjustments. So in this case, we could downweight individuals here and upweight individuals here, based upon those proportions. I'm not going to go into the details of that. Thomas Lumley is the name you want to know. He wrote the survey package in R. He has a textbook. You're generally not, if you ever get to that place where you need to do, it's a very niche thing that you need to do. So that's reason one, is you want to be explicit. The second reason is often the simple random sampling can be expensive to implement, right? It's actually has to do with costs. So in the case of when I'm talking about what the Department of Ed does, when they need to collect this data, they literally need to go to the school. So they have to travel there. They have to print things, right? So they use these kinds of approaches to reduce the cost of actually collecting the data. So those are sort of the 2 major reasons I can think of.
Right. And the strata are based on shared characteristics, right? And so if the characteristics asks for, or there are 7 or however many strata there are in that example, then that's how many strata you're going to have. But if your categories of interest that are important have smaller numbers of strata, but larger sample sizes within each stratum, then that's how it is. And so that is probably another reason why you have more or less strata.
FOMBA? Is the B hard?
The B is hard.
Okay.
So I think I'm having difficulty differentiating stratification and cluster sampling. They all seem to be dividing up a population into groups and then sampling that group. So what is the difference here?
So really the key difference is in stratified, you're defining your groups, your strata, and you're going to sample within every strata. When you do cluster sampling, you're defining them. We tend to call them clusters now. So you're going to first randomly select clusters and then randomly select within those, right? So the red is what's being sampled, right? So here under stratified, we defined 5 strata, and we're going to do some sampling in every strata. So the classic example is ethnicity, right? We might have a bunch of ethnicities. We define them, and then we randomly select individuals within each of those ethnic groups so that we have representation. Cluster sampling, right? The clusters are generally not going to be something that is meaningful, so or that we're going to cycle through. So I would not say I'm going to define 8 ethnicities and only randomly select 3 ethnicities to sample. So in this case, it's sort of more geographic, right? Is the only example I can think of, right? In these large national studies. So I'm going to say I'm going to define New York City, LA, or maybe regions or something like that, and then I'm going to go visit those regions and do that. And a lot of times these only work. So for NAEP, it works because every 2 years, they do 2 things. every 2 years, the clusters that get selected are different, right? They do a new random selection. So over the course of years, they still get a good representation of the nation, right? Their goal is to try to provide estimates of the population, not of individual students or schools. Okay. The second thing they also do is they have some clusters that are always included. So in New York City, LA, Houston, I think, Chicago, right? Major metropolitan areas where there are a large number of students and schools. Those are clusters that are always in the study. The different schools every time, right? But different. And then for rural America, they pick different ones every 2 years. So this really comes down to cost savings is mostly why you end up using these kinds of designs to make random sampling feasible that otherwise would not be. But we're, nowadays on computers, we're used to just send a blast text message and hopefully somebody responds. All right, we're going to go over just a little bit. I think we kind of already talked on this. I think this XKCD is really funny to me. I saw, is it Fair's a question? I'm not tonight going to talk about it, but if I do, I'm going to put a link if you're so interested. I talk a little bit about it at the end. Hopefully I can see it easily. Didn't I do it last semester? Regression.
By the way, we found all that stuff in the bridge course, and we were all going back and forth about it.
Oh, really? Here's a link to my talk from the spring on propensity score analysis if you want to look at that. Okay, so principles of design. Okay, so we have all those things I think pretty. Let's just get to this summary plot. Fumba, do you still have a question? Oh, I think I can put no, I can't.
No, I'm good.
Okay. Yeah, there are little icons still up. I just want to make sure. All right, so let's look at this as a way, right? So there's two things we're trying to do with our data. We want to know whether or not we can make a causal inference or not, and we want to know if our data is representative of a population or not, right? And so we kind of have this 2x2 grid. So we can have random assignment, but not random sampling. And this is actually how a lot of causal studies are done. There is, Angela, help me out. What is the what was the acronym for the criticism of psychological experiments of the last? Weird, yes. Okay. So there's this notion of that they call weird studies. It's white, European, I can't remember what it stands for. Weird studies. Is this it? Tell me what the acronym stands for.
That looks like a podcast.
Yeah, you're right. That's not what I want. No, weird studies in psychology. Maybe that'll get it to me. Weird stands for Western, educated, industrialized, rich, and democratic, right? So if you've ever taken Psych 101 or anything like that, right, we think we know a lot about how humans behave. But the criticism is all those studies are weird people, Western, educated, industrialized, rich, and democratic, right? So what we think about learning and stuff is that apply if you're from Asia, right? So there's questions about that, right? And so that goes to, because it wasn't random sampling, right? In fact, people criticize some of that research a lot. It just tells us a lot about 18 to 22-year-olds that go to college, because those are the people who participated in a lot of these psychological studies, right? So we can make causal claims because they did randomization. You do this, causes this. But it's not generalizable. It doesn't tell us anything about Americans at large, right? So we could have no random assignment, but have random sampling. That's great. That's a lot of observational studies. That tells us something about the population, but we can't necessarily make causal inferences from it. Okay. Now, sometimes we have no random sampling and no random assignment, and that's just a bad observational study. I don't know what you're going to do with it. But sadly, a lot of data science predictive stuff falls in this box, right? So be aware of it. And right, oh, sorry, I'm sorry. Most experiments are down here in this lower left. The upper right, right? So you can randomly select somebody and then put them into a random assignment. That's the ideal, but very hard. You usually get one or the other, in my experience. Okay, one last thing I want to say about causality is, why is it the gold standard, right? And what is really causality? Okay, and I like to get foundational. The textbook says it's gold standard. It is the gold standard, but the randomized control trial is already a compromise, okay, to real causality. And now that we have the Marvel Cinematic Universe, I think people are sort of at least now familiar with the multiverse, right? So if we really want causality, what we would need to do is take whatever we're interested in the causal effect to be on. So in Angela and I's world, we are interested in causal effects on students, right? So we want to take one of you. I'm going to pick Tony because so we want to know whether or not this intervention is going to work on Tony. So what we're going to do is split the multiverse such that we have two Tonys, but everything else in those two universes are exactly the same. Everything has to be the same. In one universe, though, he gets our treatment, our shock therapy, and in the other one, he doesn't. And then we're going to measure some outcome at exactly the same time on our two Tonys. And the causal effect is that different, right? That is impossible, right? And researcher Holland, who was a student of Donald Rubin, kind of coined this, the fundamental problem of causality. So what the randomized control trial does is, we're saying, well, if each student goes down and we're going to put them in condition A and condition B, any other confounders that may impact that outcome in those two universes will balance, right? If it's truly random, we should have 50% female or whatever, whatever the proportions are of, sex or, gender identity, whatever it might be, right? Overall, it should balance, right? And the one way to look at this is here on the left, I have 30 students, okay? And I'm representing their true causal effect. And the assumption I'm making here is I have an intervention, and the intervention leads to an increase of 4.5 points. Now, if you want to be concrete about this, I designed this to say it's a mean of 100 and a standard deviation of 15, which happens to be the characteristics of the IQ test. All right. So you can think, if you want to be concrete, I have an intervention, and if somebody gets this intervention, I will increase their IQ by 4.5 points. So if the student started with an IQ of like 80, after my intervention, they're going to have an IQ of 84.5. But if they start over here at 90, or I guess this is maybe 120, then their IQ after the intervention will be 124.5. Okay. This is the fix. So here I'm saying these are the true counterfactual. This is true causal. So what is a randomized control trial? Well, I'm only going to observe one of these outcomes for each of these students. So for this first one, they got assigned to the treatment. So that's why I have a red dot over here. For the second one, they were assigned the control. So I observed their blue dot, right? And so what do? Well, I take the average of the red and the average of the blue. Okay. Now, I picked this, I set the seed, the random generator seed, so that I would get this result, right? Here, if I do this, the difference is negative 5.3. So here I did a randomized control trial that not only gave me the wrong counterfactual difference, but it's in the wrong direction, right? But as we'll learn over the course of the semester, if I do this lots of times, so here I did 500, so I took this 30, and created 500 random samples where I randomly select one of the outcomes. Here's the distribution. And in fact, the mean of all of those is about 4.5, right? So again, right, the RCT is a compromise, but on average, it works. And that's kind of my point here. And if you go to that link about the PSA talk, that's a statistical method that we try to, kind of exploit this and make ways of adjusting, knowing that so the path going to universe A and universe B, the probability of being in universe A is 50%. The probability of being in universe B is 50%. And what quasi-experimental designs try to do is say, well, if we know it's not 50-50, can we calculate what the probability of going each way? And then we can make adjustments there. But that's a topic actually for another course. All right, so that concludes the slides. We'll stay on and take questions. First week we went over. I did not plan that. But here's the 1-minute paper, if you could fill that out. But yeah, we'll take questions if there's any. Tony, go ahead.
Hey, I'm in this field of data engineering, and I have a really dumb question to ask all you math people. If you go into Tableau, it's always, this is related to chapter 1 and vocabulary and metric types and stuff like that. If you go into Tableau, it's dimensions and measures. If you go into Domo, it's dimensions and metrics, and so on, right? Everything, there's this concept of dimensions and measures and metrics. That wasn't covered in the chapter. And you could, of course, if you had like US and then California and then Los Angeles and then something street and then house number 1 and house number 2, if you had those, I guess that you could say city would be a categorical variable to describe that. But you could also say that I'm a mammal, but I'm also a human. So my question is, for me to say I'm a human instead of a mammal, I think that's about 95% the right thing to do, and 5% I should say I'm a mammal. So my question is, in the world of math, is something, to me, it seems like it's 99.5% more useful to describe something as a dimension than a categorical variable if it does impact uniqueness.
I see what you're saying. Yeah. So next week we're going to define quantitative and qualitative variables more formally. So
apologies.
No. How would you know that? So it's interesting they call them dimensions. So yeah, if you can represent something quantitatively, in general, that's the right way to do. There are exceptions, right? And we'll talk about Likert response data, because survey people who give, strongly disagree to agree. You did a couple of them for us in the self-regulated learning. People generally want to convert those to quantitative variables. So you say it's a value from 0 to 4, right? But that's not entirely appropriate, I think. Then you also have cases where you have quantitative variables where you want to kind of cut them up. And that is also problematic. So the short answer I'll say for now, Tony, is if you can represent something quantitatively with more fidelity, I would say, that's generally better. However, as we go through the course, you're going to find when we have small cell sizes or small counts or skewed distributions, things like that, those quantitative measures can be a little bit problematic, and we're going to be tempted to kind of quantify them. So it's dimensions. I think what they're calling dimensions, I'm guessing, is what I would call a variable, maybe a qualitative variable, meaning it's got some kind of category. But if you can have a more refined category, that is often, not always, better. I hope I got to that. You might want to hold on to that question as we go through the next couple of lectures.
And spend be a continuous variable because it ends in cents and it doesn't end in half cents, but time is not. ending in half seconds. It just goes on forever.
So, no, I would consider them both quantitative, but one may be interval and one may be truly continuous, right? Like a real number. So if you're counting days, right, you're in days increments. But if depending on the, it gets kind of a little bit fuzzy, but yeah, I think you would still count them as quantitative. I almost always count dates as quantitative, whether they're measured in days or seconds or even months, right? Sometimes we measure things in months, but if you're looking over decades, it's pretty fine grained. So, I don't know. I don't know if I have a general rule. Angela, you unmuted. Were you gonna? Oh, did she freeze?
No,
Oh,
I'm here. I'm
oh.
here.
So a lot of times it's like when you have more than 20 unique values, then I start to think of it as a quantitative variable. And for me, the reason for 20 is, well, no, I don't know if I want to go down that path yet, but if you think about measuring, you have 20 people and you're going to you ask them a yes, no question, whatever you might think it would be. Each individual is essentially contributing 5%. Okay. It's a way to think of it. If all 20 people said yes, you have 100% yes. But one person changes their answer to no, the mean is now 95%, right? So one person can shift that mean percentage by 5 percentage points, right? So that's often still a lot, right? That's a big contribution. So, so a lot of times we'll see 20 as sort of like a minimum, but more is better, right? So then somebody has less influence. And so now that mean metric of that percentage is going to, be less influenced by a single individual. So, and that kind of counts like if you have, other kinds of measures and you're counting like 1 to 20, right? So people have tried to cheat in the Likert response data literature, the survey response data. People have tried all sorts of tricks. Like you've probably taken surveys where they give you a slider instead of giving you 5 choices, right? And the reasons why they do that is it's, to me, an artificial sense of variance. And we'll define variance very technically probably next week, I think. So anyways, we're getting ahead of ourselves.
Thank you.
Any other questions?
For our surveys, should we use their school mail or should we use the mail that is by? Or does it matter?
Just use the same one every week. Decide what you're going to use now, and please use the same one every week.
This was for the 1 minute paper you asked?
Yeah,
me?
yeah.
Okay, yeah, I had the same question. And is it due by tonight, Professor?
I would highly recommend doing it right now. It should only take you 1 minute. That's why we called it a 1 minute paper.
Okay. Follow-up question about that. I'm sorry. Yeah. So I've already finished it. If I did this wrong, then I'm sorry, and I'll fix it next week. No. So I used my school email, which is what I put in the email field. My browser is sort of default locked into my personal email. So if you know what I mean? So I'm signed in as marley.mirianthopoulos@gmail.com to Google. But in the email field, I put marley.mirianthopoulos69
Yeah, that's fine. We look at the field that you input. I don't remember seeing did it say it recorded your Google account with this form? I thought I turned that off.
I don't know. I just had a notification at the top that said you are signed in as this person.
Yeah,
you can change it here.
Let me take a quick. I thought there was a setting. You
should be good actually. I don't think it records your Google account, because some surveys do, but this is only recording the email that you put in.
Yeah.
Professor, will you share the slides for each of our weekly meetups as well?
Yep. So what will happen is the video converts from Zoom. So I try to get it up the same night, but sometimes it goes up in the morning. For some reason, sometimes Zoom takes longer to do the conversion and YouTube takes longer to do its thing. So So here's the intro to the course that we did on Friday. So you'll get the YouTube here and then the link to the, oh shoot. That's right. This will be fixed when I re-upload. I put a link to the slides right there.
Oh, thanks.
So it'll be right with the, so you can get it two ways. It's on the homepage. It's also under announcements. So you can just look for it. Probably within an hour or so. Usually I can get it up.
Under, announcements.
Yeah, it's right on the, or the
It's weird.
homepage.
Yeah, because it's giving that error.
Yeah. So I put in the wrong file name for the slides. So as soon as I pushed another GitHub, this intro to course slides will be up. I'm surprised no one noticed. So it was a test. No one noticed I made a mistake. But I noticed that I fixed it already. I just didn't push to GitHub yet. So
I have one more question. I'm
Sure.
sorry.
no, you're fine.
It's part of one of the question in the lab one. It's after the, should I read out the question, Professor?
Yeah, or I
just
can
want to
pull it up.
understand.
Yeah,
Okay.
which one is it? Or just give me the beginning.
It says make a plot that displays the proportion of the boys born over time. What do you see? Does the Abronauts observation about boys being born in the greater proportion than the girls hold up in the US? So yeah, I think that's the one.
Yeah. So I
So-
think somewhere above is going to be
The
a bar plot.
Okay.
So they gave you a brief introduction to ggplot here. So did not they did lines. So all right, well, I'll give you the hint. I'm sorry, there should be a hint in there. You're gonna
Yes.
look for you're gonna look at geom bar is what you're gonna want.
Okay.
Right. So that's gonna
So what I
Um,
was trying to understand is, am I comparing the boys or the girls?
Oh, wait a minute. No, you're not going to use geom bar. I'm sorry, I misread the question. No. So you did the line plots, right? So
Yes,
if
I
we
did the
look-
line plot actually.
Okay, so if we look at trying to find it here, right? So here's the okay. So let me put that down here. Okay, so but are we staying with that one? Okay, so we have year over, so total, right? So this is total. So if we look at the Arbuthnot,
Mhm.
right? So if the question is asking you, display the proportion of boys born over time. Well, you calculated that already, right? We have boy
Right.
ratio.
Yes.
So I'm going to give you the answer. So you just have to change this to boy ratio.
I did that for the previous question.
Oh, and I do that all the time.
So I thought that I have to compare with the present data set. There's two data set, right?
Yeah. So up above, you're going to have oh yeah. So we can change this to present, but I didn't do all the calculations yet, right? So I would need to do present. So boy ratio. I forgot the variable names. So it would be boys over boys plus girls.
Total, right? Yeah.
Well, yeah, I guess I could have done the total in between. Right. So here's the present. You're going to compare it with the Arbuthnot. So we can do, here's the Arbuthnot and here's the present. So if I knit this, these two plots would be right next to each other, or you can do this. So I'll leave the rest to you, but notice the scale on the y-axis. Seems to be,
that's what
I did the calculation, more boys than girls. Now,
Fern, I think your question is, you're asking if what you're supposed to compare, right? So what you're doing here, you're using actually the present data set, right? And earlier on with the guided practice, you use
the
Arbuthnot.
Arbuthnot, yes.
Yeah.
So this question is asking do the patterns that you see with that data set hold up with this present data set?
Yep.
So that's the question that it's asking.
Okay.
Yeah.
Thank you.
I'll show you something kind of cool. We'll talk about this next week. I can leave ggplot blank, and I can put present here and say I want to make present blue. I could do another geom line and take this and make the color red. Oh, well, I mean, I forgot. They're different years, but you know, I don't know if that helps or not. Actually, you can see the rain. I mean, the red is, although we'll talk about this when we talk about plotting. This bugs me. We're going from like 51 to 53%.
Right.
So, you know, you could do Y lim. I know we haven't talked about this yet, but oh, actually, no. 0 to 1. Sorry. There we go. Right. So this is the full range of what values could be. Right. And so we talk about law of large numbers. This will make a little bit more sense. But both cases are slightly above 50%. There seems to be a lot more noise in Arbuthnot's data set. But you could go, you know, you could play around with this, maybe 0.3 to 0.7. Keep it symmetrical, I guess. That's still, I guess, maybe let's try 4 and 6. So we're just covering 20% of the range. So so just interpret this plot at this point now.
Gotcha. Okay. Thank you.
I'll throw this in the chat for you.
I actually have one question.
Yeah, go ahead.
Yeah, because I did the whole assignment, but I only answered the question. So is that okay?
Yeah, I'm gonna guess that's fine. If it's not, we'll give you feedback and resubmit.
I don't think I asked this on Friday, but how should we refer to you?
Oh,
Blue,
I'm fine with
Jason.
Jason. Yeah, and Angela. Are you okay with Angela? I don't want to presume. Yeah, first names are fine.
One more question, Professor.
Yep.
In the Blackboard, when we submit our homework, will we able to see if they're graded? How am I doing throughout the program? Like, what would be my?
Yeah, Blackboard. We'll put it when we go through and grade. Usually put some notes, either in the notes field. So you look for those. I always forget how students see it. I think you can see it in the grade book.
I didn't see any grade option at all. That's why I was wondering. Like on the left side, I did not see any, you know.
Really? Wait, there is a way that I can switch to a student view. You don't have. Yeah, my grades. Do you not see this?
I did not see that. I mean, I didn't check today, but I checked it yesterday.
Why is that link hidden from students? Okay, hold on. Show link. So I gotta do that 2 more times. I don't know why that would have been hidden. All right. You should have it now.
Okay.
There you go.
Tools and migrate. I can see that now. Thank you.
That's that comes from, I'm sorry. That comes from the central template, and I'm just surprised it wasn't visible. I'm sorry about that. I didn't even notice. The little icon to tell me it was hidden is very subtle. All right. Wow.
Jason, can you go back to that slide with the I guess the 2x2 grid?
This one?
Yes, I just want to take a screenshot of that.
Oh, yeah, it'll be up on the site shortly.
Thanks.
Too.
I took it too, printed it out.
Yeah, it's a good I can't take credit for it. I think Minnie made this one.
What exactly does it mean, generalizability?
So you take a random sample and you're going to calculate some metric that we'll talk about those metrics. Like take a poll. Are you going to vote for the Republican or the Democrat? And so you sample a whole bunch of people and you get a percentage. X percent say they're going to vote this way. If it's a truly random sample, then that percentage should represent, with some error, but within a certain kind of margin of error, what the nation as a whole is going to do. Okay, that's what we're talking about, generalizability. I'm making an inference about this data I have, and if we want to know, can I generalize that inference to a broader population? And you got to define your population, right? Oh.
Yeah, so I'm wondering if there's different criteria of generalizability. So let's say I'm doing a medical study and I do randomly sample, right?
Yeah.
I might miss some smaller demographic groups. And so yes, it's generalizable to the average American, but it will not be generalizable to subpopulations that are rare in the population as a whole.
Yep, that's right. So, and that can be, that kind of goes to that weird people, right? So define your population carefully. And when you have rare groups, that's where like block designs might come in, or, you know, the stratified sampling.
Right.
And even though you might be randomizing a random sampling, it's still important to then take a look at your actual sample and see if that's representative of your population of interest.
So do we only really do that when we're trying to make a general conclusion about some group? Is that what it means by observational study?
Yeah, so observational is so hopefully you have more or less some kind of just random sample, and but you didn't control anything, right? You just observed things, you measured some things, right? So that's what we mean by observational studies.
Gotcha.
And I think that is not not assigned the cases, right?
I'm sorry, say right, there's no assignment. Yeah, they weren't assigned to cases. Yeah. Anything else? All right, well then let's call it a night. This is great. I'm sorry we went way over. I warned you that this might happen. I didn't think it would happen in week 1, but here we are. I hope this was valuable. We don't mind, but yeah.
Did the people in 607 in Peter's class have a Slack channel to talk to?
I don't think we do.
We have the Discord chat, but that's
you guys are
nice.
using Peter's using Discord? Okay.
No, we set it up.
Oh,
yeah.
You're more than welcome to set up another channel in our Slack if you want.
Okay. We already got a Discord thing set up, and we've been sort of, we're good, I think.
Okay, whatever. Yeah. Less I have to manage.
Go see the blue moon. There's a nice big moon right now.
Yeah, we gotta go.
Wait, what?
Oh, I see it right
All
there.
right. Bye.
Bye.
It's not really blue though. All right, see you everyone.
All right, thank you so much.